Hi, welcome in this last session in the PyCharm room for today. Our first speaker is Trebing, who's going to talk about getting in control of your workflows with Airflow.
So, hi, welcome to my talk. Yeah, getting control of your workflows with Airflow. I'm Trebing, and I'm working as a software developer at Yonder. So we have a booth also here. If you're interested, later on, just drop by and ask any questions. So, imagine the following scenario, which I know personally from my daily life. You are at a data-driven company. Each night, you get data from your customers, and this data wants to be processed. That's how you make money. Processing happens in separate steps. So, for example, you have to take care that this data is valid. You have to book that data. You apply some machine learning steps. You have to take decisions based on the results of the machine learning. And if errors happen, then you need to get an overview of what happened, why did it happen, when did it happen, especially since most of this stuff is running at night, and you need to see it next morning what possibly went wrong. And as you already might have guessed, you have a tight time schedule. So time does matter, and processing time. What options do you have to work in that, to realize such a scenario? The first thing that comes to mind of most developers is doing it with Cron. And we also had many projects where we started with that. It's a great way to start. It works out of the box, but you only have time triggers. You cannot say this cron job depends on that cron job, please start afterwards. You just say at some time, start. So for example, at 22 o'clock, book your data. At midnight, do the predict run. And at 2 o'clock, do the decide run. Besides that, the error handling also is hard. You always have to search for the correct log files when something went wrong. So now, as I said, we have a tight time schedule, and you would like to get finished earlier. So as we see, each of these steps roughly runs around 1.5 hours, so why not compressing that? So we could do better. We could here start the predict at a half before midnight, and at 1 o'clock start to decide. Works most of the time, but sometimes your database is slow, sometimes you have other issues. And then one run takes longer. Here the book data run maybe takes 10 minutes longer, the data is not there, the predict run fails, the decision run fails, your completely run fails, which is very bad when you discover it the next morning, because your customer cannot get the data he wants. So that's an issue with Cron. Because of that, when we used the Cron mechanism, we always had buffers. And yeah, if the schedule was not too tight, that worked fine. But what about the next step? Our customer sends more data, the processing time gets longer, and we need to find better solutions. Why not writing our own tool? It's so simple. We just have to check that the first run stopped and that the next run will start. That cannot be that hard. And the start is very easy. In multiple projects, we did that, and it worked for the first steps, but afterwards, you see the limits soon. You have maybe concurrency, that you have multiple tasks running at once. You need to know why what task failed. You might not only wanting to do timely triggers, but also trigger manual things afterwards. You might want an UI or an external endpoint. At that point, you have to take a decision. Either you can accept the limits, that's fine, or your own workflow implementation gets much more complex than you thought initially. So you are stuck. We were in that situation also. We wanted to harmonize all these workflow tools we had in our different projects, and we had to look at several open source implementations. There are many interesting things with many different properties. So, for example, we also had to look at Spotify Luigi, but this was more an HDFS-based tool, which was not in our technology stack, and also several other tools. In the end, we decided for Airflow, which is an open source project initiated by Airbnb, therefore the name Airflow. Why did we decide for that? Well, the tool itself is written in Python. We know that and we like it. And the one thing that was really cool is that the workflows are defined in Python code. So they are not sitting in some JSON files, not sitting in some database rows, but really each workflow is a Python code. You can enter it in your version control system, you get all versioning, and that's really a very good way of managing that. It has most of the features I said you will run within the limitations. So you can have a look at the present and the past runs. It has logging features. It's great that it's extensible, so you can write your own extensions in Python code and plug it in without having to modify the open source code, but it detects these plugins. I'll tell more on that later. It is under active development, so at the moment it's an Apache incubator project, and people are reacting on the pull request, so there's lots of traffic in there, and you can see that it gets further. It has a nice UI, which I will show you. You can define your own REST interface, and it's relatively lightweight. You have 2 processors on a server, and you need a database to store all that information. How does a workflow look like? This is the Python code I talked about. Mainly, it is a dynamic acyclic, not a directed acyclic graph, each workflow, and you instantiate it, you give some parameters like when is the first run, what scheduling do you have, you can give that in Cron syntax or in other, in time deltas also. And you can define your workflow steps as operators. So here, I tell more about the operators later, but we have 3 steps. We are booking the data, we are predicting, and we take the decision. And the connection between these steps you do via the set upstream. So you say, before the predict happens, the book data needs to happen, and before the decide happens, the predict needs to happen. So this should be, the graphic doesn't work here, but okay, let's go to the next complex stuff. So maybe you want to have a fan in, fan out. We have more data, and the predict run takes longer. We want to parallelize that, and maybe we say we do some prediction for German customers and some prediction for the UK locations. So by that, I can say if you predict Germany, predict UK, both depend on the booking of the data, and the decision depends on both of them. So it's very nicely to describe, and it will give you that graph directly. By that, you can build arbitrary complex workflows. You also have the possibility for decisions and for switches, but at least for us, we did not need them up to now. So most of our workflows are quite linear, or just with a few branches in there. So how does the nice UI look like? I already promised you. You have here an overview where you see what workflows do you have, what is the schedule of them, and also what are the statuses most recently. So it's a little bit small to read, but you have here saying which tasks, how many tasks have run correctly, how many tasks are running currently. Also you can see what are erroneous and what are currently up for retry. You can run each view, you can have a look at each DAG run explicitly. So you see here the sequence. This is color-coded also, that you can see which step was successful, which is currently running erroneous, and so forth. So this is a run that did not start. So this is just scheduled, but starting was not done up to now. The tree view shows you an overview of all the runs. So here you see each column is a run day. So you see for each day here, these 3 days went correctly, all green. And the last run currently had an issue here within the second step. It's yellow, this means it's up for retry. So you get a nice overview on how did it behave in the past and currently. Also, which helps in that is a runtime view, for which you can see, for example, performance degradation, where we see here we have 3 runs, and these colors are all different tasks. So let's say this is the booking data step, the blue one, this is the prediction step, and this is the decision step, and you see one behaved the same, and the other 2 changed over time. So very useful for seeing which of the steps might have taken longer. You can see each run also as a Gantt chart to see when was each step happening. And you have a log view, which really is useful, where you can output things like, unfortunately it's a little bit small. Here it says the decision task has started a job in the backend system, and the job ID is 17. and the next iteration, it asks what is the status now, and then we see it is finished. By that you can see how each task was processed. Now, what are the building blocks of your workflows? These are operators, and there are already many operators delivered in Airflow. As an example, you can start things on the bash, you can start things with HTTP request, you can execute statements on databases, you can write directly Python code which is executed, or you can send mails. And this is just a few examples. There are more in Airflow delivered. They're not only these operators, but also sensors. Sensors are steps in your workflow that wait for things. So an HTTP sensor could, for example, always query an URL and ask whether it is finished or what is the status on that. And based on that, it will wait or it will proceed in the workflow. In the same way, an HDFS sensor could check for files on the file system, and an SQL sensor could check for values in a database. Many things already you can do with these operators, but there might be situations when you need more. For example, for us, we had an asynchronous processing in our backend systems. So we had here our Airflow system, we had our backend system, for example, the machine learning system for the predictions. We wanted to start a job, so we trigger an HTTP request there. We get back a job ID, and then we let it run for 5 minutes, half an hour or so, and we constantly ask whether it is finished or not, and when it is finished, we can start the next job. This would be possible to do already with standard methods of Airflow. So we could use the simple HTTP operator to start it, and the sensor, as I described, to wait until it is finished. This works, but it has the disadvantage that you don't see directly how long did it take. So you remember the last view with the runtimes. I would like to see how long did my decision take, and therefore I want that this step decide has a certain length, and the length is the length that it took on the backend system. So this is possible. We can do this with a new operator. I won't explain each line in detail. Also, you can find afterwards this as a complete Airflow example plugin on a GitHub repo, which you can see afterwards and can check for each line. So we have an HTTP connection defined. We have some endpoint decide that we can trigger that, and it delivers us a job ID, and we have a job status. We can ask when we have the job ID, what is the status of that. So within the execution, we run the post on the decide to get back the job ID. Then we wait for the job with this job ID, and once the status is finished, we are done. And then within the Airflow database, we know how long did this decision step take. Now, how do you get these operators into your system? As I said, we don't want to modify the code, the Airflow code directly, but we can do this in a Python package. We can say we have this plugin that has some own operators, that has some Flask blueprints, and lay that in our file system and in the Airflow configuration. We just can say your plugin is here and your workflow definitions are there, and on the start of Airflow it will detect them automatically. Also that plugin is defined in Python. As you can see here, we have the Airflow plugin manager, and you just say inherit from that Airflow plugin. We have our EuroPython plugin. This has 3 operators I need and also a blueprint. What is it about that blueprint? Why do you need that? We had the requirement, we wanted to have an endpoint to talk in a REST style with our Airflow system, so that we can also programmatically say, I want manually to start a trigger. I want to know, is a DAG run finished or not? This functionality was not there in Airflow, but you can write it as a Flask blueprint. You can define that endpoints, and it is detected automatically and added within the web server. Also this you will see in the example repo. How would such a REST endpoint look like? We have here the Airflow server running on port 8080. We have defined this endpoint trigger, and we say we give the name of the workflow, which is daily processing, and we get back the name of the workflow and a run ID, which we can use afterwards to ask for the status. So this works fine. Now what happens inside of Airflow It works with two processes. At least two processes, I should say. We have a scheduling process that takes care when each job should run, and we have a web server that gives the UI and all the other blueprints. Also, you need a database. Several databases are supported. We are using at our company the Postgres and the SQLite. SQLite currently has a restriction that you cannot run parallel tasks on them. But we are using the SQLite more for the development testing stuff, so this is fine. And for production, you can use the Postgres, and there you don't have that limitation. You can also look how do you want your tasks to be executed. We are using most of the time just HTTP requests. We are saying we trigger a task in the backend system, we're waiting until it is finished. So the Airflow system itself, there's no high workload on that. So we are happy that this runs within the scheduler process directly, or when we want to have multiple tasks in parallel, we work with sub-processes. But it's also possible if you trigger the stuff via bash scripts or similar things that you want more power behind the executor nodes itself. And to do that, you can use Celery, which is a framework with multiple worker nodes, and you can use that. There is already a connection from Airflow to Celery. Yeah, how we use it, most of the things I already mentioned in the meantime. We use the automatic schedules and we have manual triggers. We use one Airflow instance per system we manage, so we also had how do we that connection, do we have one central company Airflow instance or one Airflow instance per system, and for us it was easier to do it that way. Databases, we use Postgres and SQLite, the executors are lightweight, and also we are contributing to Airflow. This is really good. That works fine. These external triggers that you can trigger them manually, they were not there 1 year ago, and we needed them definitely before using Airflow, so we wrote a pull request that was also worked with, and now within these two pull requests, this is an Airflow. And we also have some necessary functionality for the plugin detection, so we also open pull requests there, and there's an active communication with the community. With all these good things about Airflow, there are at least a few challenges I want to make you aware of, because these were things we struggled a little bit, and also with the project teams using Airflow at our site. This has to do with how is scheduling handled and how is the start time interpreted. So scheduling, there are two dates that are important for that. It's the start date. This means when did the processing of this task, of this workflow start on the server. So that's quite easy. It's the time of the server. But there's also an execution date that is quite prominently shown on the UI, and that sometimes shows strange values. These values are consistent and they are explainable, but they are not always obvious. The reason is the history from Airflow. So this was used in ETL scenarios, so this extract, transform, load. And this means that for each, they wanted to process daily data, which was coming in the whole day long. So let's say on 19th of July, the whole day data came in, and then you wanted to process that data for the 19th of July. And when can you process that data? You can process it only after the 19th, which is the 20th. So let's say today. So today, this task of data processing runs, and what is the execution date? It's the 19th. So it's always one iteration back. This is because they said originally, well, this is more a description, this is the data from the 19th, therefore it's the execution date. That's fine. When you know that, it does not scare you that you think the system is doing wild things, but that's consistent. But yeah, you have to get used to that. We have some workflow starting in a weekly schedule, which means when I trigger that now, it gives me the start date of Monday the week before. Also that, it's consistent, but you need to get used to that. Then we have the start date. You might remember 10 minutes ago that we give a start date for each workflow. And if the workflow is scheduled automatically and you start the server, it will know that it has to fill up tasks. So when we say start date is today, 20th of July, no, we start the server at 20th of July, the scheduler, and as start date we have given the 17th of July, then it will detect that there are some runs missing, and it will fill these runs automatically. So it will first trigger the run for this with execution date 17th, then execution date 18th, and as a regular run, then the 19th will be processed at the correct point of time. You need to check whether this is applicable for you. So when you have these things, I need really to process this data, that's fine. When you have more the thing, I want to trigger something in the back end, and I need to trigger it just once, because this backend job will take care of all cleaning up that stuff, then this is a little bit strange and can lead to issues when you trigger it too much. But you can work around with that when you give the correct start time already. So you can determine that in code, you can determine that in a variable. There are several options, I won't discuss them in detail, but this is the thing you should have in mind when you do that, when you wonder why does this backfill happen. It's possible to handle that, but you need to know the concept behind that. If you have some further questions, maybe we can discuss afterwards. Okay, and that's it also from my presentation. I give you here, that's the incubator project for Airflow. It has a nice documentation, which is here. Also very useful is the common pitfalls page in the Airflow wiki. There also the stuff with the execution date is explained in more detail. And the plugin, which I have shown you parts of, you can find here at our Blue Yonder repo. You can download that. You have the steps in the README on how to use that in your Airflow instance. So that's it from my side. Any questions?
Yes, hello, thanks for the presentation. You showed us the GUI. Is it possible to manage task dependencies in this GUI, or is it just to display things that you wrote in the code?
The workflow definitions itself, you do that in code. So you can view that code from the GUI, but you have to change it in your code editor.
Okay, because well, in our firm we've got a homemade scheduler, and well, with I think 100,000 tasks inside. And is it scalable, Airflow? Do you use this amount of tasks in your system?
No, we don't have that high data volume in our system. So for us, it's more that we have per systems these nightly runs that have several tasks, but not thousands or millions of that. I've seen in the documentation page from Airbnb, these DAGs seem to be much bigger, so it would be worth to ask them what is the limit for that. But we did not reach it up to now.
Hi. I would like to ask about the execution date and the run date.
Okay.
Like, is it possible to configure it? Because we have like similar example when you collect data for last month and you want to run it, for example, 15 days later, or in the opposite direction. You want to like collect data for next month and run it 50 days before that. Like, is it if you can configure it, like the delay, or maybe even if you can postpone it. If you see, okay, I will run tomorrow, but if I have no data tomorrow, I will retry the day after tomorrow.
Well, at first, the logic is not configurable. So this is in the scheduling code itself. Regarding the stuff running 2 weeks after or 2 weeks from now, I would say I have no quick answer to that. Maybe we could discuss it afterwards. I think you can do many things with the scheduling. So because the scheduling just tells you when does it run. You also have the possibility to schedule a run each day. And as a first task of the run, decide on whether you really want to run or not. So this might be the first iteration when you say you implement the more complex logic than in your first task, but maybe there's also other things.
Okay, thank you.
Okay, let's have one more question.
Did you evaluate other tools when you decided about Airflow, and why did you decide for Airflow?
Yeah, for example, we had to look at Luigi, but that was based on an HDFS stack, which we did not run. So therefore, this was too heavy weight just to have a workflow system to set up this. We also had to look at several OpenStack implementations. but their main focus was on doing heavy work lifting with execution processes and how these are distributed. And since we had very lightweight processes but needed more UI features and more possibilities to define own operators, this also just was not the main focus. When you see these two things, great, but the main focus is a different thing, then yeah, it's good to have a look at other tools.
Because in theory also Jenkins does a lot of things like that with some plugins. So if you already have Jenkins, you have to convince your team to use something else. So what could be one thing that you can do that otherwise you cannot do?
I mean, Jenkins is great. We also use Jenkins for our integration testing, for scheduling our unit tests, but not for the daily productive runs.
Okay, let's give a big hand to Christian.